Okay, so in the previous video, we learned how to move the ball around. And now in this video, we're going to be learning how to detect penetration between two balls, resolve the penetration, and also provide a collision response whenever the balls hit each other. So as of now, if we create a new ball, and let's just turn controls off for this and move this 300 pixels to the right. We also have to draw them and reposition them every frame. You're going to see that they don't actually collide with each other and they don't move each other. And the way that we do this is, if you see over here, the two balls are intersecting right now. There's two things that we want to consider when resolving the penetration. First, it's the distance between the center of the ball. So from here to the center of this ball, this distance we have to consider. And also the distance, or the penetration depth, as I like to call it, the penetration depth of the two balls. And the way that we're going to separate them is we're going to move the balls in opposite direction in a distance of half of the penetration depth. So if we move this ball half of this distance, and this ball half of that distance, they're going to be no longer intersecting each other. So let's do that. So our first method is going to be isPenetratingBall. And this will detect whether or not the ball is penetrating the other ball by returning a true or false value. This true or false value will be dependent on the following formula. So what this formula is essentially doing is it's returning a true value if the sum of the radii of the balls is greater than the distance between the center of the balls. Because at that point, that means it's penetrating the other ball. Also, what we're going to do is resolve the ball penetration. So first, we're going to calculate the distance between the center of the balls. Then we're going to be determining the depth of overlapping, or the depth of penetration. Then we're going to determine a penetration resolution. And we're finally going to apply resolution onto the balls. So for the distance, it's going to be this.position.subtract ball.position. Then the penetration depth will be this.radius plus ball.radius minus distance.magnitude. And this is the distance over here between these two. Then the penetration resolution goes in the same direction as the distance and is equal in magnitude to the penetration depth divided by 2. Then we apply this resolution onto the balls. And this one will have a negative value because it's going in the opposite direction. So now let's add it to the balls. So const is colliding equals if ball 1 is penetrating ball 2. Let's just put this as is penetrating. So let's console log this value and see if it's working. So right now it's false. And now it's true. See, right when they're penetrating each other, it returns true. So this is working. So now if it's penetrating, then what do? We resolve the penetration. So what we do is ball1 dot resolve ball penetration ball2, and that should work. There you go. You can see that whenever the ball touches the other ball, it moves it away. However, you're going to notice one thing. There's still a bit of penetration going on. And I'm not exactly sure why this happens. However, I've come up with somewhat of a fix. So what you do is you do penetration depth plus equals this. So we leave this the same. And what I've noticed is that the distance at which they are still penetrating each other is dependent on the velocity. So what I would do in this case would be to determine the velocity magnitude along the distance vector. And so in this case, distance vector is distance. So what we do is we do distance dot this dot velocity. So this is the velocity along the distance vector, and then we divide it by distance dot magnitude. So this is the velocity magnitude along the distance. Then we do, and then we get the velocity along the distance itself. So I just noticed that I made a mistake here. I'll fix it. So we do distance dot unit. So it's in the same direction as the distance, but then we multiply it by the velocity magnitude along the distance. And I believe we can also divide this by 2. And then we just add it to the penetration depth. So this should work. I think we should move this here actually. And so now, there you go. You could see it's reduced. It's still somewhat there, but it's much less. And yeah, I mean, I'm not sure how to exactly fix that. Maybe it's just on my screen, but it is what it is. Now we're going to be resolving the ball collisions. So we're going to do resolve ball collision. So first we're going to get the unit normal vector of the collision tangent. And the collision tangent is essentially, you can think of it as a line, a tangent line between the exact point at which they intersect. So as you can see over here, these two balls over here, they have a line, just a normal at the center here, like that. So the normal will be this dot position dot subtract ball dot position, and then dot unit. Now we're going to need the relative velocity of ball 1 to, or actually, sorry, ball 2 to ball 1, which in this case, ball 2 is ball over here, and ball 1 is this. So const relative velocity equals this dot velocity dot subtract ball dot velocity. Then we need the relative velocity along the unit normal. So now we create the relative velocity along the unit normal, and we're going to use this to calculate the amount of velocity that's going to rebound the balls away from each other. So we're going to calculate a separating velocity, and that's what we're going to call it. It is equal to the dot product of the relative velocity with the normal. We're also going to create a new separating velocity, And we don't really need to create this right now, but I'll show you why later on. And this is going to just be the negative of separating velocity. And I'll show you why this is the case later on. Then we also have to get the vector of this, so separating velocity vector, and it's along the unit it's along the normal, so there you go. And then that's essentially just the, and so this is the distance that we're going, or the velocity that we're going to be using to bounce the balls off of each other. So this dot velocity is going to be this dot velocity dot add separating velocity vector. We're going to do the same except multiply it for 1 for the second ball. And I believe it should be working now. See, there you go. Now whenever you bump the balls into each other with a lot of velocity, the balls bounce off of each other. At the moment we don't have a mass, but we're going to be implementing that later. So anyway, that's the collision response. And so the next step for this would be to add masses and calculate the amount of movement or the impulse that's applied onto the balls based off of their masses and the ratios between them. And so in the next episode, that's what we'll be talking about. I'll see you then.